Welcome back, guys. My name is Anita Raj, and today I'm going to be doing another lesson for eCoreAcademy. This lesson will be under my Algebra 2 course. Before I even get into the content I have planned for you guys today, please like this video, subscribe to our channel, and share the channel with all your friends who you think might benefit from it. It really helps us and shows that you guys really appreciate this content and that we should keep expanding and keep bringing you more content. So please pause the video and do that first. All right, once you've done that, I want you guys to bring your attention back here so we can talk about what we're going to be going over today. So today we're going to be doing correlations and linear models. Yesterday I posted my video of the part 2 part of it. This is part 1 of it. This is part 2 of 2. So this is the second and final part. This was a pretty hefty lesson, so I wanted to split it into so it'd be easiest to digest. So we're going to be continuing where we left off. So in the last video, we went over some vocabulary. I showed you some pictures of what correlations look like, and we reviewed TI calculator functions with correlations, scatter plots, trend lines, etc. However, here we're going to be actually applying them. So we're going to be doing 3 practice problems. The first 2 are just kind of straightforward practice problems to see if you know how to use your calculator and the functions I taught you in the previous video. And then the last one's going to be a bit of a challenging word problem that I made, and I will be walking you through it. Again, for most of these, I have a by hand part, so if you don't have a calculator with you, please just look at those instructions, and then I have a calculator part. So those of you who do have the calculator, you use that part. So, without further ado, let's get into the first section. So we're going to be doing actual applications. Like I said, the first 2 problems will be straightforward problems. The last and third problem will be an actual application I made. So we're going to be trying to solve these for ourselves so you guys can actually see how you can apply correlations and linear regressions to life and real-world problems. Without further ado, let me just change my screen over to my calculator so I can demonstrate on that as I walk you through these problems. Welcome back, guys. I just changed my webcam over to my calculator so you could see me do the functions on that and do these practice problems along with you. Again, we're going to be doing 3 practice problems. The first 2 are pretty straightforward, and the last one is a word problem. But don't worry, I'll be walking through all of them with you. So right now, if you have a TI calculator, preferably an 83 or 84, please grab that so you can follow along. If not, don't worry. For all these problems in the solution section, I've written how you can do them by hand. For the last one, I haven't specified it because it's a little bit more of a complicated word problem. You should probably be using a calculator for but nevertheless, I'll still explain to you how to do it if you're doing it by hand. So no worries there. Okay, without further ado, let's get right into these first problem. The first one's on scatter plots and correlations. So let's see what it's asking us. Given the coordinates below, can you make a scatter plot and identify the type of correlation? So the coordinates given to us are listed right here. There are 5 of them. They are 0, 6, 2, 7, 3, 8, 4, 8, and 5, 11. So given these coordinates, we have to make a scatter plot first, and then we have to identify the type of correlation it is. So we're going to be doing the scatter plot on my calculator, and you can do it if you have one. But for those of you who don't have a calculator, I just did like kind of a preview of the final answer that we will be eventually getting right here, and I put it here. So the green coordinates are these 5 coordinates plotted on the grid. And then additionally, on top of that, I just made this line of best fit or linear regression. We'll be doing that as the next step, which is like part B of this problem, which is the second question on the next slide. But just for sake of preview, so you guys can see it all on one coordinate plane, this would be what the linear regression looks like. So again, these are the coordinates, 5 coordinates here, and then this is the line of best fit. But we're still going to be doing it on my calculator, so come over to my calculator here. So first, we want to make a scatter plot. In order to do that, we want to put these 5 coordinates in a table. So to get to the table, we want to hit stat. Then we want to hit stat, and then we want to hit 1 for edit because we're going to edit the table. L1 are your x coordinates and L2 are your y coordinates. So we're going to be copying those exact same 5 coordinates into this table. Treat it like a normal XY table. So we're going to do 0, 6, 2, 7, 3, 8, 4, 8, and 5, 11. So those are our 5 points. So they're all in our table right now, and they're all set to go. And what we're going to do is we want to see these coordinates on the actual graph. So we're not going to be graphing the linear regression yet. We're just going to be making a scatter plot where we just see these 5 points graphed. So if you guys remember, we need to go to our y equals and we need to enable stat plot so we can see them. So you want to hit the up arrow and you just want to make sure your cursor is over plot 1, blinking over plot 1. Hit enter to confirm that. And now your cursor is on plot your cursor is blinking over plot 1. Plot 1 is set to go, meaning it's set so that your coordinates that you just put in the table are visible. So to see what I mean, hit graph, and now you'll see the first 4 points. The reason you can't see the 5th point is because it's 511, and this is a standard viewing screen, meaning the highest it goes on the y-axis is 10. So we need to adjust the window. So we hit window, scroll down to your y-max, because that's what we need to adjust, and change your y-max to 15 so that you can see 511, that last point. And if you hit graph again, it's extended, and now you can see all 5 points, which is what we want. So this scatter plot is ready to go. This is going to be your final answer for this part of the problem. So this is set. Let's go to the second part of this first problem, and that is us identifying what type of correlation it is. So if you guys remember types of correlations, they can be strong or weak, positive or negative, moderate, non-existent. So we need to describe the kind of correlation this is. First of all, let's see if this is a strong, moderate, or weak correlation. So if I just drag my finger through these coordinates here, trying to mimic a line of best fit, they are pretty strong because these coordinates kind of form a line. They are pretty close together. If they don't form a perfect line, but they are pretty close together. They almost look like a linear equation. That's why we write strong. This is a pretty strong looking correlation. So is this positive or negative? Well, it's increasing from left to right, which means it's positive. If it was decreasing from left to right, it would be negative. So if the points were scattered this way, where my finger is going down from left to right, then it would be a negative correlation. However, it's increasing from left to right, so this is a strong positive correlation. Okay, let's go to the next slide, which is the second problem, but it kind of builds off of what we just did. So now we're going to be looking at coordinates and trend lines. So given the coordinates below, can you give the equation of a trend line? Just so you know, these are the same coordinates as the last problem. So again, the 5 coordinates are 0, 6, 2, 7, 3, 8, 4, 8, and 5, 11, the exact same coordinates. So right now we're going to be doing a linear regression. I've already showed you how to do a linear regression in my previous TI calculator videos, but I'm still going to be walking you through it now in the form of an actual problem you might see on an assessment that's testing your ability to use the calculator. So I just want you guys to note that the linear equations we find are predictions, as in the trend line or line of best fit. They're not the exact linear equation, because already you guys can see these coordinates don't form a perfect line. We're just making a prediction of the best line, the prediction that goes through these points and makes the best prediction of what a linear equation would look like. It's a prediction. It's not exact. Okay. So the first part of the solution I want to show you is doing the solution by hand. So this is for you guys who don't have access to a calculator. It's perfectly fine. You can still do linear regressions by hand, and I'm going to show you how to do it. So first, you want to pick 2 coordinates from the list. So I'm going to go back a slide, and this is the list again. For the sake of this solution, I just picked the first 2, which were 0, 6, and 2, 7, just because they were smallest and easiest to work with. So if you guys remember from my Algebra 1 review video, if you have 2 coordinates and you're trying to find a linear equation, you can do so as long as you have those 2 coordinates. You can find the slope and the y-intercept, and you're good to go. You just need 2 coordinates, and you can do it that fall on that line. And in this case, we have 5 to choose from, so we can definitely find the linear regression by hand. So again, we just picked 2 random points. This is not going to be the exact linear regression, but it's going to be a pretty good approximation. So again, we chose 0, 6, and 2, 7. First, we're going to find the slope between these points. The formula for slope, remember, m is your slope, so m equals your y1 minus your y2 divided by your x1 minus your x2. So what we're going to do here is we're going to do m equals 7 minus 6, so your y1 minus your y2 divided by 2 minus 0, which is your x1 minus your x2. And then 7 minus 6 is 1, 2 minus 0 is 2, and then you get your slope to be 1/2. So then we found the slope. So now we have to find the y-intercept, or b. So we're going to pick a random coordinate. And right now, what we have so far of the equation is y equals 1/2 x plus b. So we're going to be picking a coordinate. For this case, I picked 0, 6. And we're going to be putting 0 in for x and 6 in for y. That's a coordinate. So we can pretty much just put the x coordinate in for x and the y coordinate in for y, and now our only variable left is b, so we can solve for b. So what I did was 6 equals 1/2 times 0 plus b. So 1/2 times 0 is 0, 6 equals 0. 6 equals 0 plus b, and then if you just subtract 0 from both sides, b equals 6. So your y-intercept is 6. If you guys didn't already notice, this coordinate was 0, 6, so this was already the y-intercept. You didn't have to go through these steps, but I just want to show you how to do it. If you didn't see that, there's always this, you get to the same answer, so there's no problem. So then after that, you put it all together to make a linear equation. So your slope is 1/2, your b is 6, so you put it together and you get y equals 1/2 x plus 6. So that is a pretty good approximation of what the linear regression would look like, and that's if you solve it by hand. So just so you know, it's not impossible to solve it by hand. But the main part of this problem I want to show you is how to solve it with a calculator. Your teacher might assess you specifically on your ability to remember how to do these functions on the calculator. So first, to find the linear regression on the calculator, you want to enable scatter plot. You just want to go to do this. We already did this, but I'm just going to walk you through it if you're just doing it now. So first, you want to hit second, which is, if you look up at this picture, I'll show you where the buttons are. So second is right here. Then you want to hit y equals, and you want to make sure it's on, and then you choose the first graph, which is scatter plot. So let me show it to you on the webcam on my actual calculator. So I hit second, and then I hit y equals, and then I can hit 1 to go to plot 1. And then I just want to make sure my cursor is blinking over on. And then if it's on, then I just hit enter to confirm. And then if I hit down for the type of graph I want it on scatter plot. So just use the left arrow if you're on a different one of these, and make sure you confirm scatter plot by hitting enter. Make sure your x list is L1, meaning your x coordinates are in your L1 and your y coordinates are in your L2. Because if you remember from our stat, this was the table we used, and that's L1 and L2. So make sure that's correct. So you'll be set there. So then you want to input your coordinates. So in order to get to the table, you want to hit stat. If you guys come up to the picture, I'll show you with the cursor. So you hit stat, and then you hit 1 for edit, and then you enter your x coordinates in L1 and your y coordinates in L2. We've already done this, but I'll just show you if you didn't do it. So if you're on the home screen, you want to hit stat, and then you want to hit 1 for edit, and then you just enter your x coordinates in L1 and your y coordinates in L2, and you're set to go. And if you hit graph, you should be able to see them. So next, you want to actually calculate the regression value, meaning we actually want to calculate the linear regression or the line of best fit. So in order to do so, we want to hit stat. Stat is right below the delete key. Then we want to scroll right to the calc menu, and then we want to hit 4 for linear regression, which is ax plus b. Then we want to scroll to store regular equation. Then we want to hit the vars button. The vars button is right here where my cursor is. Then we want to hit right to go to the y vars menu. We hit 1 twice. We hit the down arrow to calculate, and then we hit enter to confirm. So let me actually show it to you guys on my calculator. So in order to do this, you want to hit stat. Then you want to go right to the calc menu, and then you want to hit 4. 4 is linear regression ax plus b. Then you're right here, and make sure your x list is L1 and your y list is L2, like I explained to you guys. Then you hit the down arrow, and you'll go to store reg equation, and then you want to hit vars, which is right where my index finger is, and then you want to hit right to go to your y vars menu. Then you want to hit 1 for function, and then 1 again for y1, and you'll return to the screen. Then you want to hit the down arrow so your cursor is on calculate, and then you want to hit enter to confirm that. And then you'll be given this new screen. So after that, you want to write down the linear equation prediction. So A is your slope, which is m, and B is your y-intercept, which is b. So what I mean by this is, look how the calculator gives the form to you. They don't give you y equals mx plus b. They give you y equals ax plus b. In this case, A is just substituting m. So A is your slope. So here, A, they're giving you the value 0.878, etc., which I rounded to 0.88. For B, they give you 5.54054, which I approximated to B equals 5.54. And if you put it all together and you write it as a proper linear equation, you get y equals 0.88x plus 5.54. So if you guys go back to your graph, you'll see that line graphed. And make sure, if you go to window, make sure your window settings are properly adjusted so that you can see all 5 of the points we wanted to see graphed, and then you can see this whole line of best fit passing through them. So if you guys see, we have our 5 coordinates graphed and the line of best fit graph. So this is how you would tackle this problem. So let's go to the next slide. And now we will be doing the harder part of the video, which is the word problem. So I know word problems may be daunting to you guys, but let me walk you through this. Please feel free to pause, rewatch, do whatever you need. But we really need to tackle this so you guys can get a taste of what word problems will look like when you move to Algebra 2. Okay, so the word problem says, below is a table of tree heights recorded over the course of a few years after being planted. Can you find the equation of this line? What is the tree height during year 7? When will the tree be 45 feet tall? So there are 3 questions, and they've given us kind of an outline of what the table below represents, and they've also given us the table. So let's read it again. Below is a table of tree heights recorded over the course of a few years after being planted. Can you find the equation of this line? What is the tree height during year 7, and when will the tree be 45 feet tall? So right now, just imagine it this way. You're someone who's planted a tree, and over the course of years, you've been recording the tree height in feet, and you've recorded it all in this table below. As you can see, your x are your years, and then your y is your height. So your x is your dependent variable, your time, and then y is your height, which is x is your independent variable, and y is your dependent variable. Your height is dependent on the years. So your years are 2002, 2004, 2005, 2008, and 2012. So, and your corresponding heights are 3 feet, 10 feet, 14 feet, 40 feet, and 77 feet. So you want to find the equation of this line. If you guys notice, this graph does not form this table that we've given you. It doesn't form a perfect linear equation. So in this case, you're going to be putting coordinates on the grid, but they're not going to be they're not going to be perfectly in a line. We're going to be finding a linear regression or line of best fit that best passes through these lines and best gives us a linear equation that identifies the pattern of growth. So first, we want to find the equation of this line. Let's tackle this first question on the next slide. And I'll constantly be changing back to this slide so that we can refer to these questions and this grid and the instructions. So let's look at solution part number 1, which is our first question. So first, I want you guys to let x equal 0 correspond to the first year, 2002, and every year after follow. So what that means is when you're doing applications and you deal with years, you might be dealing with years like 1967 or 2014, years like that. But if you guys look back to this table, can I make the coordinate 2002 3? That's just not plausible. You can't have an x coordinate that has the value of 2002. Therefore, what we do with word problems, especially when you're in Algebra 2, the first year that they give you, you assign that as year 0. So you're pretty much rewriting the x values. So in this case, 2002 is year 0. We're going to call this our first year, so we're calling it year 0. We are renaming it so it's easier for us to graph on the TI calculator, because you're not going to be putting 2002 into your x value, because then your graph will be it's going to be very tedious for you to change your window and everything to accommodate for that. So we're going to make x equals 0 correspond to the first year. You do this with the first year of your word problem. So in this case, it's 2002, and every year after follow. What this means, if 0 equals 2002, 2 will equal 2004, because 2004 minus 2002 is 2. So there's a 2-year difference. So if this was year 0, to maintain that same relationship, 2-year difference between 2002 and 2004 becomes year 2, 2005 becomes year 3, 2008 becomes year 6, and then 2012 becomes year 10. So these years are found by subtracting the actual year they are from the year 0. So if you guys just see that pattern, I think it'll be easier for you to understand. So just pause the video and try to understand that pattern for yourself. And I also rewrote it in a different table right here. So your x values have changed 0, 2, 3, 6, 10, and your y values have stayed the same, 3, 10, 14, 40, and 77. Again, we just rewrite the x values. They haven't actually changed their quantity, like as in the year they correspond to. They still correspond to the same year, but we're using a different kind of scale, so it's easier for us to graph it on the calculator. So now, by hand or with your TI, find the line of best fit. So before we even do that, I just skipped a step. We need to actually put these points into your calculator. So for this sake, I'm just going to restart my calculator, second mem 712, and I just reset my calculator because it's just easier for me this way. You don't have to, but I would recommend you do just for sake of practice. So then what I want to do first is I want to put these points that I have up here on this table into my actual calculator. So I'm going to hit stat, then 1 for edit, Now my L1 and L2 are clear, so I can put these points in. So the first point is 0, 3. The second point is 2, 10. The third point is 3, 14. The next point is 6, 40. And the last point is 10, 77. So now all my points are in the calculator. Just to make sure I can see these on the scatter plot, I want to hit y equals and make sure my scatter plot's on, so I can just hit the up arrow. When it's blinking over plot 1, I can hit enter to confirm, and now my plot is on. So then when I hit graph, I should be able to see the points. However, I can only see my first point and then half of my second point. I can't see my other 3.5 points, for lack of a better phrase. So in order to do that, you guys might have already guessed, you need to change your window, because again, this is your standard viewing screen. This is your 10 by this only goes up to 10 on the y-axis. However, my largest y value is 77. So I'm going to go to window and I'm going to scroll down to y max, and I'm going to just change this to 80 to make sure I can see that last point. And then what I'm going to do is, if you guys see my largest x value, it's 10. So I don't want it to be right, my graph to just encompass right on the edge of that 10. So I'm just going to, for good measure, I'm just going to change this to 15 so I can see my graph the best possible. And then I hit graph, and you guys can see, I can see all 5 of my points. This one's not really visible, but it's right on top of the y-axis. But I can see all 5 of my points, so I'm good. Then what I'm going to do is, on the TI calculator, let's take a little pause. So if you're doing this by hand, I'm not going to show you the actual workout by hand, because this is the kind of problem I would really prefer you guys to be doing on a calculator. But let's say you really don't have access to a calculator, that's fine. I'll show you how to do it on hand. First, you want to pick 2 points. For example, I would preferably pick 0, 3, and 2, 10, because they are the smallest points to work with. You want to find the slope, which you're just subtracting y2 minus y1 divided by x2 minus x1. So you can just do 10 minus 3 over 2 minus 0, or 3 minus 10 over 0 minus 2, however you want to do it. And then you'll find the slope, and then you can pick a point like 0, 3, and then find the y-intercept by plugging 0 in for x, and then 3 in for y, and then your slope in for the slope, and find the b, because that's your only variable. Or if you already realized it, 0, 3 is the x-intercept, the b would be equal to 3. So you can definitely do this by hand, but if you want the most accurate answer, I would suggest you do it with your TI, and I'll show you how to do it. So with your TI, put the coordinates in the table, which you already did. Then you want to find the linear regression. So to do that, we're just going to do the exact same thing we did in the last slide, where we found the line of best fit through those first 5 points. So we're going to hit stat. Then we're going to hit right to go to the calc menu. Then we're going to hit 4 to go to linear regression, which is ax plus b. And then we're going to hit the down arrow to go to store regular equation. Then we're going to hit vars, hit right to go to the y vars menu, then hit 1 for function, and then 1 again for y1. Then hit the down arrow so your cursor's blinking over calculate, and then hit enter so that you can get the linear regression. So again, the linear regression is in the form y equals ax plus b. A is your slope, which is m, and b is your y-intercept, which is b. So you should be, if you're writing this as a proper linear equation, your answer should be, I rounded it off, so your answer should be about y equals 0.60, y equals 7.68x minus 3.47. So that's the linear regression you would get. So if I hit graph, you guys can see the line of best fit passing through these points. So that's how you would solve the first part of this problem. Let's go to the next slide. We're going to be addressing the second part of the problem. If you guys forgot, we have 2 other questions. So we're going to be tackling the second one. What is the tree height during year 7? And then the next slide we'll be doing when will the tree be 45 feet tall? So let's do what is the tree height during year 7. So if you guys remember from previous calculator videos, I showed you guys how to make predictions using these models, meaning we are given an x coordinate and we can find the y coordinate, or we're given a y coordinate and we can find the corresponding x coordinate. You're going to be making predictions. So in order to find the tree height, you are given year 7. So what is the tree height? So we're trying to find the tree height when the year is 7. So on year 7, we're asking what is the tree height? So to find tree height, you're given year 7. That's the information you're given. So year 7 is 2009, because if you think about it logically, we assigned 0 to 2002. So if this is year 7, it's 7 years ahead of year 0. And if 2002 is year 0, if 7 years ahead of 2002 is 2009. So 2009 is year 7, because 2002 plus 7 equals 2009. And so that's the year we're trying to find the height of. And this is a given x value because remember, years and time are your x value, your independent variable, and now we're trying to find its corresponding dependent variable, which is the y. So we've been given an x value. We can identify that the prediction is going to be based on us being given an x value, so we're trying to find a y value. So in order to do that, we're going to do second, trace 1, input 7, which is the number of the year, and then hit enter. So we're going to hit second, then we're hitting trace, and we'll go to the calc menu. Then we want to hit 1 for value. And if you guys remember, x equals, and here we've been given year 7. So we're not going to be typing 2009 because remember, we're using a different scale and we're measuring this on year 7. So we're going to be hitting 7 on your keypad. So x equals 7. And we're going to be finding what the tree height is, or the y coordinate is corresponding to this. You hit enter and you get y equals this amount. So you'll be given the corresponding y value, which is the height of the tree because it's a coordinate. So this coordinate matches. So time goes along with the height. So our answer is the y coordinate, which is y equals about 50.32 feet. And you found that using a prediction. So we're going to go to the third and final part of this question. So when will the tree be 45 feet tall? So we'll be using the calculator to make a prediction again. So right now we've been given to find the year. We're trying to find the year. So what have we been given in this question? We've been given the height. So therefore we want to find the corresponding year. So you're given 45 feet, and feet is a y coordinate, which is a y value. Therefore we're trying to find an x value. So the prediction is based on us being given a y value, and we're trying to find the corresponding x value as in the year. So in order to do this, we have to do it a little differently. If you guys remember making predictions, we need to graph a horizontal line of the y value, which is 45. So you want to go to your y equals, go to your y2, type 45, graph, second, trace, 5, and then hit enter 3 times. Let's do it on my calculator on the webcam. So I'm hitting y equals, and then I'm hitting the down arrow to go to y2 because in my y1, I already have the line of best fit equation. I don't want to tamper with that, so I'm just going to go to my y2, and my cursor is blinking there. I want to type 45, just 45, because I want to graph a horizontal line. Then I hit graph, and then you see that red line, which is my horizontal line. The point where the horizontal line and my line of best fit intersect is my answer. The x coordinate will be my actual years, which is my final answer, and the y coordinate will be the height, which is 45. So in order to find the point of intersection, we want to hit second, then trace, and then go to calc, and then we're going to be calculating the intersect point. So we're going to hit 5 for intersect, and then we're going to get first curve, second curve, and then guess. It's going to be asking us each time. So to confirm each question, we want to hit enter. So the first time it asks is first curve, hit enter, second curve, hit enter again, guess, hit enter a third time. So we want to hit enter 3 times. And then the intersection, it gives you the x coordinate, and then your y is 45. So the x is your answer. That's the years. So you'll be given the corresponding x coordinate, which is the year, because it is a coordinate. The time and the height go together. So here I have rounded it off to x equals 6.31. That's what my calculator reads right here. However, this is not your final answer because it's asking you when the tree will be 45 feet tall. So if someone was asking you this question and you said it'll be this tall in year 6.31, would they understand that? No, because that's the scale that we are using for our convenience on the calculator. You need to convert this back into real years. So in order to do that, you're just going to add 6.31 years to year 0, and year 0 is 2002. So 2002 plus 6.31 is between 2000. It's going to be equal to 2008.31. So for the sake of it, you would just say between 2008 and 2009. Between 2008 and 2009, your tree will be 45. Your tree will grow to be 45 feet tall. So remember, when you get this final answer, x equals 6.31, that is not your final answer. That's the final answer that the calculator gives you. However, you need to convert that back into real years. And to do that, you just add that value to your year 0, which is 2002, and then you approximate it between 2008 and 2009. So that's how you would approach this part of the problem, which is the third part. And that's all I have for you guys today. I know I went through those pretty fast, but please feel free to go back and rewatch the parts that you were confused about, especially that last application, because those are the kinds of problems you will be seeing quite a lot in Algebra 2 when it comes to real-world applications. But trust me, once you get the gist of it, how the wording goes, how to approach different predictions, when do I use a prediction for X, when do I use a prediction for Y, when do I calculate the linear regression, you'll be able to answer all these questions in a matter of seconds after reading a problem once you get into the hang of it. So don't worry at all. All right, guys, so I'm going to be wrapping this video up. Before I do, please like the video and also subscribe to our channel so you get notified of future content, and that you can also follow along with my Algebra 2 playlist. It'll be super beneficial to those of you who have finished Algebra 2 and are going into pre-calc and need a refresher, or those of you who are fresh out of geometry and need to get ahead before you go into your Algebra 2 class. It's super beneficial, highly recommend, and the way you can do so is by subscribing. You'll be notified of all the content I post. Also, we have a Facebook, Twitter, and Instagram now, so I notify you of all our recent posts of YouTube posts. I also link it there. So if it's easier for you guys to share with your friends through those social media platforms, please find us on them and follow us, and we'll follow you back. We can always start a correspondence on there as well. Please help us expand to the student community, because you guys know teenagers love social media, and let's make the best use of it. And we're also going to be having a website going up pretty soon. It's going to have a lot of resources on it, as in special note, like handmade notes from AJ and myself, and questions we make ourselves for you guys. Like, it has everything that our YouTube cannot give you. So it's highly recommended that you go and you make an account on there as well when we have it up, and we'll be informing you through our YouTube, through our social medias when it goes up. So you will definitely be notified. And lastly, if you have any personal or business inquiries, please email us at eCoreAcademy@gmail.com. If you don't want to just drop a comment down below, definitely reach out to us there. We check our email very frequently. So that's all I have for you guys today. Please stay safe during COVID and make the most of your time. Try to make a difference on others by positively impacting them in any way you can. All right, have a great evening and see you next time we post.